With that, I'd like to introduce our first presenter, Bert Mueller from Sure Controls.
Thank you very much, Ryan. Again, I'm Bert Mueller, Sure Controls. So Sure Controls, we're a specialty distributor of integration and automation equipment. And we're located up in the lovely state of Wisconsin, at least during the 4 months out of the year that's not snowing. But we've been around since about 1984, and we specialize in 5 key areas: robotics and advanced automation, essentially the discrete part handling, plant intelligence, web handling, thermal and fluid processing, and safety. And as you can see, we're like a family here and love to have fun together, work hard, play hard. And we gauge our success based on our customer smiles. We've done a great job and exceeded expectations, then our customers reply with a smile to us. And that's why we say plant automation to make you smile. A large focus of our team is on rapid deploy and redeploy solutions. So these are going to be solutions that you can use in one area, and then as your needs change, take that over and redeploy it somewhere else. For example, the robot, the collaborative robot, can be placed onto a mobile cart that's either manual that you push and move up to location where you need it, or even on an AGV or a autonomous mobile robot, where those would guide themselves to the preset points that you have and then do the automation step that you need. Lab automation is a big one with that. And the system can also be used then for doing things such as pick and place, machine tending. Maybe you grab the part off of the line, pull it over, and move it in front of a camera and do an inspection, then drop it back off again. And the intent is that these are quick to set up, and then once again, as the needs change, which they inevitably do, you can retask this elsewhere. And we look to also do other things with the part. So once you have control of the part, you can do other types of processes. So you can do AQI, which is automated quality inspection. You could maybe take it and do some sort of an assembly, snap a couple pieces together, put an O-ring on, kit it, where maybe you're putting multiple parts into a single package. We've all seen go to the doctor's office and they pull open a package and it's got all the little components in there that they need to perform the procedure. And then we have machine vision and auto ID, so camera-based technologies to check parts for assembly and quality. And then we also work with flexible in-feed and out-feed. So don't really use the feeder bowls so much anymore, just because those are kind of one-trick ponies. You can put parts into systems that can adapt and handle a wide range of different products. And that kind of covers my area here. So what I'd like to do is I'd like to pass it over now to Darren Jacobs. Darren's the regional sales manager at Precise Automation, and he's based out of Charlotte, North Carolina, which is, I'm jealous, a little warmer most of the year. But take it away, Darren.
All right, thanks very much, Bert. So I'd like to get started with a little bit of background on Precise Automation for those of you who do not know our history. If you look at this picture right here, you can see this is a picture that's actually in the Smithsonian Institute, and it's got a picture of the robot there and the 4 gentlemen on the team that actually developed the very first electric robot, and that was called the Puma robot. Now the 2 gentlemen in the middle, the second from the left is Brian Carlisle. Brian Carlisle did all of the electrical mechanical engineering for the Puma robot project. And then to his left is Bruce Shimano. Bruce Shimano handled all of the software development for this first electric robot. So that was very significant as far as a development in manufacturing. It actually set off, assembly robots going into manufacturing in both Europe and the United States. So after that, they were out of Stanford University. So after that project and that robot was sold to a company called Unimation, the both gentlemen decided to continue to work together, and they founded a company called Adept Technology. Adept Technology set the benchmark of excellence for SCARA designed robots, high-speed SCARA with safety fences, mainly in assembly automation and big automotive plants and many different industries. They sold that company back in 1983 to a company called Omron. And then they founded in 2004 Precise Automation. Now, Precise Automation is actually located in Fremont, California, sunny, I might add sunny, California. And it's right down the street from Tesla. They've been in, the team's been together for over 20 years. It's a lean company. We actually are one of the few companies that manufacture robots within the United States. We do that through a means of contract manufacturing with a defense contractor called Design West down in Tustin, California, or Orange County. This allows us to have pretty decent lead times on Cobots. And I might add that Cobots is really the only technology robot that we develop besides our motion controls. We do not develop industrial Cobots. So moving ahead to what we basically do, as I mentioned, the company started out with a controller design, a microcontroller design, very powerful, running on low voltages, and it could basically power kinematics or precision machines by design. And that's exactly what they did after having that design and the software to follow with it. They said, hey, why don't we go ahead and develop a Cartesian type robot? So we have the Precise Place 100 series of Cobot that is either in an XZ or an XYZ configuration. The controllers are embedded in them, so you don't have cables hanging out the back of them and going down to a big tower box and then into the power. Very clean and very easy to install. And like I said, they run off of 110 voltage. We went ahead after having those, and those are primarily used in lane changing for conveyor systems and some simple pick and place applications for tabletops. We went ahead and designed this unique SCARA design robot with the PF400 and the 3400 series. Now, both units are able to be placed on a collaborative rail that we offer in a 1 meter, 1.5 meter, 2 meter lengths. And this is a unique design in comparison to other SCARA type robots. If you look at traditional industrial SCARA designs, the stroke of the Z is out in the front, and that is limited most of the time to either a 200 to a 220 millimeter stroke. Our strokes in the back, as you can see in these pictures, they're the two black lines on the back column. We offer this Cobot in 3 different lengths. The first one is 400 millimeters, the middle one is 750 millimeters, and then the tallest one is 1160 millimeters. So these are very unique design. We're going to get more into the applications with them. But our newest product that we're about to release is actually the Precise Flex Direct Drive Series Cobot. Now this kind of incorporates design of traditional 6-axis Cobots, as well as our SCARA design here. Instead of a linear rail, we actually have a rotational base direct drive motor. And then we have a direct drive out on the elbow. You can see it in this. This was a show that we did back earlier this year, demonstrating this new Cobot, and it has a unique envelope. You can see it. This one is offered in a 500 millimeter Z stroke, a 1 meter Z stroke, and a 1460 Z stroke. And then it comes in either a 4-axis, which this one pictured is a 4-axis with a gripper on the end of it. You could call that a 5th axis. And then it's offered in also a 6-axis version. So a unique design. This will be very good when we go to machine tending applications or in feed out feed loading of conveyor systems. So one of the questions I think I get asked more frequently in my jobs when I go visit customers is, what is collaborative robots? Some folks still don't really truly understand, the utilization and the definition of collaborative. But if you look at this traditional design here of what was first collaborative, it was actually utilizing a industrial grade robot that would use a LiDAR scanner, area scanner. As the operator would walk towards the robot, it would slow down and then come to a complete stop. He would then do what he needed to do within the work area, Once he's done checking everything he needs to check, he then leaves the zone. And as he leaves the zone, then the robot will then slowly come back to working, and it will, go back to what it was doing. Now, I don't call this fully collaborative. I call this semi-collaborative, and that's because not one at the same time as the operator working with the Cobot. So what we call collaborative is in the upper right here. You can see Dalton put his hand in between the pinch point there, and it stops the Cobot, and then the Cobot goes back to working and doing what it's doing. So our Cobots are all force limited, and they all follow all of the stringent guidelines by the safety ISO safety standards. With that, I'm going to actually hand it over to Dalton to talk about teaching.
Thanks, Darren. So I'm just going to talk about a unique feature for our line of robots, specifically the PF3400 seen here. And that is really just how easy it is to drive these things by hand and basically manually teach the positions. So unlike other industrial robots like Darren showed earlier, or other Cobots on the market, in our mechanic selection, we don't actually use typical high friction, high gear ratio components like gearbox and harmonic drives. So this serves a few purposes for us. It really produces a small forward reflected inertia. And mechanically, what that allows us to do is be really sensitive on our current sensing technology, and allows us to really detect collisions and make our robots more safe and more sensitive to the outside world. And also allows us to move at the fastest collaborative speeds at 1.5 meters per second. And what you're seeing me do here is use our graphical user interface guidance motion to simply click around a few times on the screen, teach a few positions, put the robot into free mode, move it to a specific location you want, and then with just a few other clicks, you can get a very simple pick and place application up and running in no time. We do have a fully integrated 48-volt motor supply, which for typical use with these robots ends up, these things are consuming less than 200 watts on average operation. So they're really lean and they're really green, really nice. Next video, please. Another unique feature we like to demonstrate is the power of our error recovery and the low collision forces of our Cobots. It's what makes us, uniquely collaborative. And we always opt to show this famous pinch point demonstration here. And with other systems, you're going to get alarms raised on the factory floor, you're going to get downtime in the work cell, and more importantly, you're going to get an injured operator. But with our error recovery system, simply through guidance motion as seen here, we can allow for obstacle avoidance, jammed parts, as well as missing parts, and we can get the robot to recover from these errors and continue execution of the application with no attendance in the work cell. So all of our collision testing has been performed and certified by TUV, and all of our collision speeds and forces are provided in our hardware reference manuals published for your reference. So you're seeing here is just one type of collision in the work cell. It's going to make a few checks and go back to doing what it was doing. Inconsistent part presentation might be an issue for some assembly lines in feed or out feed, but you can see here with an already existing recovery routine, we can add in a part presentation system check, and then the robot will continually look for that part. And then lastly, here is another example showing an operator perhaps in the work cell, and if some type of collision happens, we can give the Cobots or the operator some time to go ahead and manually adjust the Cobot, put it into a position to say avoid some other maybe expensive hardware components, and then the robot will get back to doing what it was doing. And lastly, one thing we like to talk about is the advantages for maybe an additional axis, or we call the linear axis. And so we always show this visualization here of the traditional 6-axis work envelope. It's spherical. And you see our PF3400 with its work envelope, it's cylindrical. Now let's take that a step further, put it on a linear rail. We can, effectively double that effective work cell space. And what you're seeing me do here is simply plugging and playing with the 3400 Precise Flex onto the linear rail. So I plug in a few cables and it's that simple. It's a master and slave topology from the controllers. So it's easily integrates as an additional axis. And what you're seeing here is just an example of a storage retrieval system. And that's where this linear rail really shines, is being able to kind of go through a lot of factory space or lab space and effectively use all that space while not taking up other needed space for, say, operators or other hardware. And what you're going to see on the screen now is just some data and some talking points of how, our unique work cell design is kind of more effective, or, you might think about it a little differently when designing a factory, your cell on the factory floor. Essentially, with the traditional spherical working envelope, you can, might be able to access a wide area, but maybe not the entire volume efficiently. But with our rail and our work envelope, end users and integrators can save factory or lab space. You can access all heights at all points of the work cell. And with that being said, I'll pass it back over to Darren. He's going to talk about some applications.
Hey, thanks very much, Dalton. Well said. Actually, to build off of your linear application, look at this one right here. This is a company called Carbon 3D. It's actually a collaborative SCARA on a rail there, tending 5 different machines. So a very good application of that utilization. This is a SCARA tending some dental milling parts just in and out of the machine. This is a pretty exotic application of tomato picking using multiple cameras and vision, a little bit of AI, and then a custom gripper to grab the tomatoes. So it's on a mobile platform. It's a pretty one-of-a-kind type system. Now, for precise automation, we're very big into this type of an application, which is micro-titer plate management in life sciences, lab sciences arena. We've been very busy with the pandemic. Companies utilize this machine mainly because of the utilization, the geometry of the cylindrical envelope there. You're able to kind of really work the workspace at different levels, where a 6-axis robot would get into some trouble here at the lower point and the upper point of its range. This is another application where it's actually doing multiple tasks using a flexible feeder, like what Bert was talking about earlier. And you don't see all safety fences around this thing. Here's another one working side by side in automotive with a customer. A repetitive task that they had was placement of this magnet. I mean, it seems like a very small task, but that's what they wanted to have a robot do. Just go ahead and place that while the person's doing something else. So what do we look for when we go out into manufacturing facilities? That's something that for those of you watching this presentation, want you to contact Sure Controls and basically they'll come out and take a look at it, what you're trying to automate here. What we look for is this is actually a customer for Sure Controls with that same magnet placement, but we're looking for that person who's doing repetitive work. We're not looking to replace industrial machines here, industrial robots that are going at high speed, because that's the biggest difference is a Cobot is not trying to replace that. And if it went at the same speeds as the industrial robots that are all guarded, then it wouldn't be safe anymore. There are, certain speeds that you can go out and produce a certain amount of force that's allowable under the ISO standard. So we look for somebody doing repetitive work. We look for that small work area that we can utilize, basically. And Dalton talked about how we maximize that smaller footprint. We look for payloads under 7 kilograms. If we go above 7 kilograms, we start getting into that area where the load itself is no longer collaborative. It's really dependent upon the custom end of arm tooling, whether it can hold that weight, and then start moving it around like that. You can run into trouble in your risk assessment. We look for 3 seconds or longer. It's funny, a lot of industrials are looking for 3 seconds or faster. We're not trying to do 60 parts a minute here. This is it's a total different apples to oranges comparison when you're looking at industrial high-speed operations and collaborative operations. We put ours on mobile platforms. This is fast becoming a very hot product here. This is like a lab partner scenario where our system lends itself to the mobile platform in that we don't tether a big controller. Ours are embedded into the Cobot. So you can see in this picture right here, there's not a lot of cabling all over the place. It's pretty streamlined. It's on a nice platform, has a camera attached. It's actually going to take a picture of that and then grab that micro-titer plate. And then we do look for applications to replace an operator, not an existing industrial robot. So most of the people that are used to robots and have the industrial ones, it's very important to tell them, look, we're not trying to replace that. What we're trying to do is have you redefine your production flows, redefine your right sizing of facilities and your process development. So a closing summary of key features and benefits for precise automation cobots is our embedded controllers. That's a big one. The ability to have that embedded into the control, into the cobot, eliminates all of that, the bulkiness of a tethering controller box. Unique geometry, Dalton discussed the cylindrical work envelope versus a spherical work envelope on the 6-axis in the marketplace. Now that's a big difference between us and them, is that the majority of the cobots in the marketplace are all 6-axis. So this is very relevant when you come to discussing reachability. You know, every application has the right robot for the job, and so in certain applications, we're just going to cover more ground. We have the only collaborative Cartesian cobot I mentioned, and the collaborative linear rail. Those are big pluses to make your system completely collaborative. Fastest speeds in the industry, 1.5 meters a second, as Dalton has mentioned. A lot of our competition can only go half that speed, and they then, to go a little bit faster, they'll employ a area scanner. And then that, in my opinion, goes back to that whole scenario of semi-collaborative. When you start using LiDAR sensors and scanners with the collaborative robot. Low incremental cost, being able to deploy and redeploy, as Bert had mentioned, that's very key in this industry. If I chose automotive as a topic and said, hey, automotive production lines are multi-million dollars, and they're very inflexible. They're you know, if you make a bad design there and you kind of have a bottleneck and you have to figure out I need about 3 or 4 more robots on this line, that's going to be very difficult to retool and change, and you have to affect many aspects of the line. With cobots, what's nice is you can develop new processes, you can prototype, you can do whatever it is you need to do that you're manually doing today in a plant, and then you can go ahead and, once you're done with that project, move on to the next one and redeploy the cobot, and do that at a very low incremental cost. So we're very flexible. I kind of mentioned that in that last answer. Easy to teach by hand. Dalton demonstrated this in the video there. And as he mentioned, a low 48 volt, 200 watt cobot, which is better on the pocketbook when it comes to using power consumption, and makes it a green cobot.